Rahim. Assalamu alaikum students. So now I have a paper from November 09. It's the variant 41. It's first two questions. They are from the work energy power. So I'm on to the first question. The first question states that there is a car of mass 1000 kg. Okay, and it moves along a horizontal straight road passing to the points A and B, and it says the power of its engine is constant, and that is equal to 15,000 watts. Okay, and then it says the force exerted by the engine at the point A is 750 newtons, at B is 500 newton. So we have to find the speeds at A and B, and hence we have to find the increase in the kinetic energy. So guys, this is a basic question. You can see this is the very first question of the paper, so that is supposed to be the easiest question. So this is easy because the guys who know that the power is equal to F into V. When we say F into V, so we should be clear that this F is basically the forward force. So we are given the forward force at the points A and B. So we define first of all the speeds at the points A and B. So the speed at A is going to be using this. I can say this is the speed at A is going to be, the power is 15,000 and divided by 750. So the speed at the point A is going to be 20 meters per second. And we shall find the speed at B in the very similar way. That would be the speed at B is going to be 15,000 divided by 500. So the speed at B is going to be 30 meters per second. You can see that the speeds are increasing. The speed is increasing from the point A to B. So there is definitely a gain in the kinetic energy. Okay, so we know that the gain in kinetic energy is going to be the gain in kinetic energy, that is half into the mass, which is going to be 80, and the final speed, which is 30. So that is 30 square, and the initial speed is 20, that is 20 square. So you simplify this, you should get the answer as 250,000 joules, or you can write it as 250 kilojoule. So you see that that was a basic question on the formula of power and then the gain in kinetic energy. Now I move towards the second question. Okay guys, now I'm on to the second question. This is a bit trickier question, and this really involves the in-depth understanding of the concept of the work energy power, especially when the objects, they are moving purely under gravity. There is no forward force, there is no backward force. Okay, no resisting force. The objects, they are moving on the smooth surfaces. Okay, so now you need to understand the statement of this question. It says a smooth narrow tube. So you see the very first word smooth has to be underlined. So that would mean that there will be no resisting force. It has two straight parts, AB and DE. Now this AB is a vertical part over here, and this DE is a horizontal part. And then it says there is a curved part BCD. The part AB is vertical with A above B, and DE is horizontal. C is the lowest point of the tube. You see, this is the C, the lowest point of the tube, and it is 0.65 meter below the level of DE. So it has been mentioned over here. This is 0.65 meter below this horizontal level DE. Okay, it says a particle is released from rest. So I need to mention here that here is the speed. The speed is 0 meter per second, and it says it travels the tube, leaving at E with the speed 6 meter. So when the particle leaves the tube, it has a speed of 6 meter per second. So we have to find the height of A above the level DE. So basically we have to find this height H over here. Okay, so guys, you if I just make you recall quickly that my favorite formula, that is the work done by the driving force minus work done by the resisting force, that is the change in kinetic energy plus the change in potential energy. So since there is no forward force, there is no backward force. Okay, so you will see that this side is going to be 0. So change in kinetic energy is left, and this is going to be the change in potential energy. So if you move one to the other side, so this can be change in kinetic energy, that is minus the change in, you can put the minus to any side. You see that why there is a minus over here. The thing is, when this object, this particle, moves from A to B, you will see that the potential energy will be decreasing, and since this is moving under gravity, so it obviously has an acceleration which is g, so its speed is going to increase. Okay, So the kinetic energy is going to increase when it moves from A to B, while the potential energy will be decreasing when it is moving from A to B. Okay, so now using this relationship over here, we can find this height. Now, how do we know that what is the speed over here? So please remember, you see that this is the level over here. Okay, so the speed at E is going to be, it is 6. This is going to be 6 at this level, and this is going to be 6 at this level as well. So please, you see that I'm just going to I'll just try to explain this to you. You see that if there is an object moving under gravity, for example, it is moving like this, and it is going down like this. Okay, so you see that I have just drawn at random like this. So if I draw a line over here, for example, I draw a line over here, a horizontal line. So when I have drawn this horizontal line, so please be very clear at these points. Let me call this point A, the point B, the point C, the point D, the point E. So you must be very clear that at all these points, the potential energies will be same. The potential energies will be same. Suppose here is the level, this is the ground level from which we are going to determine the potential energy. So this distance, this, all these distances, basically the heights are same. So the potential energy, they are at all these levels, that is going to be same. Okay, so if you keep this thing in your mind as well, so you must be able to understand this, that the kinetic energies at these levels, they should be same as well. Okay, because at any of these points, you take any point over here, the sum of the potential energy and the kinetic energies, that will be same throughout. Okay, so I'm coming back to this point now. So you must remember this, that you try to understand this, that if at this level, at the point E, we are at a level of 0.65, at the point D we are at a level of 0.65, and even at the point D we are again at the 0.65 level, meter above this point C. So that means at the points B, D and E, the potential energies are going to be same. Therefore the kinetic energies will be same, and when the kinetic energy is same, that means the speed is going to be same at all these levels. Okay, so I'm just going to finish this off now. The change in potential energy over here is mgh. So I'm just going to write this as mgh, and that is going to be equal to the kinetic energy at this level, that is half m into 6 square. Okay, so you see that the m's are cancelled, so this h would be 18 over 10. This is going to be 36 over 2, that is going to be 18, and I'm just going to use this g as 10. So the height is going to be 1.8 meters. Okay, this is a trickier question. So you just see there was no forward force, no backward force, so the sum of the energies will remain the same throughout. Okay, now the second part says find the maximum speed of the particle. Find the maximum speed of the particle. Now the maximum speed is going to be like, we would take it as the maximum kinetic energy first. So if we have to find the maximum kinetic energy, so where would be that maximum kinetic energy if you think about the potential energy as well? If we say that the kinetic energy is maximum, so wouldn't that mean that the potential energy is going to be minimum? Yes. So you see that the potential energy is minimum at the point C, because this is the lowest point over here. Okay, so this was 1.8 meters. Okay, you add another 0.65 into it. So we'll just take this part now. Okay, the vertical displacement over here. So now I'm just going to draw it over here, that for example, if it is here, you had a speed 0 over here. Okay, but you are at a level which is 1.8 plus 0.65, 1.8 plus 0.65, that is going to be 2.45 meters. So this is a 2.45 meters distance to be covered vertically. Okay, so we have to find what is the V over here. So if the kinetic energy is 0 over here, then the potential energy will be 0 over here. Okay, so the potential energy at this point would be same as the kinetic energy at this point. So just like the first part, you will have to, let me say that m into G into H, that is equal to half into M into V square. Okay, the M's are cancelled, so we have let me calculate this. So this V square is going to be 49, so V is going to be 7 meter per second. So guys, this is the maximum speed of the particle on this level, like through on this track over here. Okay, I hope I tried to make it as simple as I could. So if you just still have any questions, please let me know. Thank you very much.